So yeah, I'm going to talk today about how we at Kunstmaan Accenture Interactive think of blockchain and other distributed ledgers as an ideal experience tech. But in this presentation, it will be primarily about how we use the technology to deliver those experiences. And most of the experiences that we are thinking about involves improving the lives of people, but in this proof of concept, we went a bit further. So my name is Daan, and I've been working at Kunstmaan for 10 years, and recently we've been acquired by Accenture. During my time at Kunstmaan, I did a lot of things, but primarily programming, back-end, front-end, mobile, but also been busy with UX and architecture things. And since 2016, I've been working in the blockchain team, where we've been thinking about use cases and also been experimenting with different technologies. And in the project I'm going to talk to you today, we used Hyperledger Fabric. So yeah, it's a project we did for the Flemish government, where we got innovation budget to think about how we could improve the lives of people who are involved with managing nature, like an owner of a piece of land, someone who needs to maintain it, and also the public servants themselves. But we tried to get even a step further, and we wanted to see how we could use the technology to improve the ecological, social, and economic values of nature. It's already a project we did a year ago, and I will go into the technical stuff as quickly as possible, so how we did it. But first I'm going to tell a bit about the business case itself. All the code is open source by the Flemish government, so you can find it on GitHub, but I will provide a link later on. So about the business case, in Belgium, people get subsidies for managing nature, and all they have to do for that is create a nature management plan that describes the current state of a piece of nature and the future state, so where they want the nature to be in 20 years. And until now, that was done on paper, and it was a lot of paperwork. Yeah, literally hundreds of pages in size, and it was a lot of overhead for the maintainer who needed to describe it, but also for the public servant who needed to approve it. And afterwards, when they approved it, they just stored it in an archive somewhere and never looked at it again in most cases. In fact, they hire other people to collect certain facts about nature. And most of these facts were already described in the nature management plans that they have in their archive, but they couldn't find it, or it was very difficult to find, or they didn't trust the guy who wrote it. Also, when they gave subsidies, they had no control about what they were using the subsidies for, and if they were used correctly. There was no transparency in the subsidy flow. Even if they would buy a Tesla with it, which was also ecological, it wasn't meant for that, so that was a real issue they had. And with all those problems in mind, we tried to rethink the ecosystem, and we came up with the following proof of concept. I'm going to show a small video describing what we did, if it works.
The environment. Therefore, we manage nature very closely. Woods and parks are monitored by governments and environmental organizations. Governments? That usually means a lot of administration. But what if we could manage it without hassle? Wouldn't it be fantastic if we could give people complete and crystal clear transparency? That's why the Agency for Nature and Forest and Informatie Vlaanderen of the Flemish government and Kunstmaan Accenture Interactive developed a solution using blockchain. We built a prototype application where owners, nature organizations and managers, engineering firms, contractors, and the Agency for Nature and Forest can collaborate and easily monitor the evolution of nature and the subsidy settlement. Blockchain. Yes, blockchain. It's a new technology that will dramatically change the way we exchange information. More specific, it's a distributed ledger, in which all kinds of transactions can be exchanged and verified in a trusted way without the control of a central party. It's easy to use and highly trustworthy, as all the transactions are securely stored on the blockchain. The result of our prototype is a complete new ecosystem that maximizes the ecological, social and economic value for nature and forest in Flanders. Subsidies are an important component of the application, and they're paid in the form of a euro-backed digital token. By creating this token, we made it possible to issue subsidies to pieces of land. Each piece of land has its own rules programmed on how subsidies can be spent, making sure subsidies flow to the rightful beneficiary: owners, nature managers, and contractors. In other words, this new app offers absolute convenience and efficiency, resulting in the correct use of subsidies, less administration, and more resources and people in the field. And that's not all. This pioneering proof of concept shows how we can reshape the complete government for the better. In the coming months, we will rework the prototype into a real-life application and start rolling it out. Let's use technology to re-strengthen our fragile relationship with nature and take care of it with all the respect it deserves. After all, nature means life. Want to know more? Contact us for more information.
So that's the proof of concept we created. It was really very conceptual. In reality, this would be too far. So the Flemish government wouldn't go that far with that. So whenever we do a proof of concept, we start with identifying a few things that we want to test. In this case, the first thing was we wanted to see if we could create an identity for a piece of land so that we could gather all the attributes of a piece of land in one authentic source, and also to try to see if it would be possible for a piece of land to participate in transactions. The second part was automation by continuous registration of facts instead of on regular checkpoints. So right now, every 5 years, they will see what the evolution of nature is doing, and then they can take actions on that. But by continuous registration of those facts, you can get quicker actions and maybe automatic actions through smart contracts. Also a traceable history of the evolution of nature, but also about subsidies. And then a single sort of truth where everybody is working together on the same truth instead of everyone having another copy of the truth. And then one thing we also always try to look at is the user experience in user journeys, but also in UI. Quickly going to say what the user journeys are, but I think the video almost explained everything. So there are a few actors involved: owner of a piece of land, the maintainer, contractor, and then the public servant. They are working on with some objects like a piece of land which had an owner, a nature management plan, then nature types that get defined, and then a few contracts, and then the coins. The user journey was split into 4 parts: creating a nature management plan where the owners will agree on a piece of land that gets assigned to a maintainer, that he will maintain it, and then the maintainer can start making observations. We have the maintenance subsidies, where the maintainer will ask for subsidies. The approver, the public servant, will need to approve it, and then if it's approved, the coins will flow directly to the piece of land instead of to the maintainer. And then we have the work contracts, where the maintainer and the contractor will set up a work contract. The money will flow into the contract, and after the work is done, the money will flow to the contractor. There was also an extra subsidy part there that we integrated. And then the last process was where the contractor could exchange his nature coins for euros, but we didn't do that in the proof of concept. So technically, yeah, it was our first proof of concept using Hyperledger Fabric. We had previous experiences with other technologies. It was complex data because geographical information is, it's quite complex. We had to do some intersections, and to do that with contours, it was quite difficult. Also, the Flemish government was saying that they wanted to create generic building blocks so that they could use those blocks in other projects. And yeah, and that's what we wanted to keep in mind while creating the application. And then, yeah, we used Hyperledger Fabric. It was a year ago, so 1.0 was just released. Yeah, but we used 1.1 because, yeah, it was in beta. We are coming from a web background as well, so we had a lot of Node.js developers, no Go. Yeah, we didn't know Go yet, and there were no Geo libraries for Go at the time, so we chose to use Node.js. There are a lot of other reasons why we use Hyperledger Fabric, also because we want to experiment with that and see what the technology is all about, see how the components work and stuff like that. We chose not to use Composer because they wanted to create generic building blocks, and the way we saw Composer was more like a black box that was doing a lot of things, but it was a bit magically. So we used Hyperledger Fabric to really understand like the order, the peer, how do they work together, how does the endorsements work, and so on, so that we could get valuable insights that we could give to our client. I'm going to talk about how we set it up. It's in 3 parts. The first part is about how we set up the network. I'm not really a DevOps guy, so I know high level how we did it. But if you have questions about that, I can get you into contact with who did that. So yeah, it was done in Hyperledger Fabric 1.1. Right now we are at 1.3, and I think 1.4 will be released. So there are a few things that might be outdated or can be done differently at the time. So, but I think the message will be the same. So setting up the network. We had 3 organizations that needed to work together, all organizations from the Flemish government. We had A and B, which is the Department of Nature and Forests itself. Then we had the Flemish government, it's the VO one. And then GRB, they had data about the pieces of land and who is the owner of that piece of land. We wanted to create 2 channels. One for GRB because they have private data about the owners, and then the public channel where everybody can, where all the public data or all the data that the Flemish government could know could be stored. We also stored everything on-chain because we wanted to see how far we could go if we had all the data at hand. The citizens have no node. They connect through a node from the Flemish government because it would have been too complex, but we talked with nature organizations to see if they would want to participate in it. But yeah, and they wanted to, but in the end we didn't add a node for them in this proof of concept because this would lead us too far. So this is what we wanted to create, but yeah, it was a bit difficult at the time because we also wanted to do this on multiple physical machines because yeah, we want to learn from it and to give good information to the client to see how they could take this to a production system. So it was quite complex because we didn't find any examples a year ago about how to set this up on multiple physical machines or even on an Amazon VPC with multiple machines in there. Everything was running on one node. So yeah, we thought it would take a week, and in the end it was like 3 or 4 weeks that it took. So, but we got it working on Amazon Virtual Private Cloud. Every instance was Dockerized, so we also Dockerized our application, and then we used the Docker overlay networks to connect the containers together. And that works when it's running on one machine, but because it was on multiple machines, they couldn't find each other. And that's why we used console at the time to share the settings of the Docker overlay network. So if one instance spins up, the console instance will make sure that the settings are shared within the cluster, the console cluster that was created. Because if you want to set this up on multiple machines and also on one machine, there are a lot of things that need to happen, and they need to happen in a specific order. Yeah, we created a lot of scripts for that, and we used Vagrant to orchestrate the setting up of the whole network. And then for the certificates, at the beginning, our idea was to integrate this with the Belgium EID, but then after a few meetings with the client, we saw, or they told us that it wasn't a good idea, but they had other systems in place that we could use. But we wanted to keep their certificate structure because, yeah, it was a good structure. You had the thing with the citizen certificates who only has user certificates, and then you had a second branch where you have all the service certificates, where you can create a chain of trust with each department having their intermediate certificate that could create certificates for all their services. So we wanted to create this, but also, yeah, we looked at Fabric CA for that, but at the time we also found it very difficult, not that much information, especially when you're working with intermediate certificates. So what we did is we created scripts that where we could just generate this kind of structure. So all the things we created, we gathered them and combined them in a tool that we open sourced, where it's possible to just create a configuration about how you see the network, and then run the script to generate all the artifacts, all the certificates, user certificates, service certificates, all the MSPs will be generated. And then there's also a script using Vagrant to spin the whole network up on Amazon AWS. Right now it's still a mix and match of different scripts because we did it while we were learning the whole, how Hyperledger Fabric was working. So, but we used it on other projects as well, and it saved us a lot of time. Yeah, there are also scripts, things in there to update chain code, to generate new user certificates. So, yeah, it really is a replacement of the Fabric CA as well. Then developing the chain code. I'm not going to go into too much detail because all the chain code is also available online. I'm just going to talk about a few concepts we try to integrate. We're not sure because if it's the right thing to do it that way because we were learning by ourselves at the time, but we find it quite we found out that it worked good. So first thing was separation of concerns. So we created 9 chain codes, each with their own responsibility. Chain codes also could talk to other chain codes. This way they're more maintainable and a lot smaller. And a lot smaller means it's easier to maintain. Also because they were saying that they wanted to create generic components. So in here there are a lot of things that they could reuse in other projects as well, like access management and identity management. I think almost everything is quite generic. Only the nature management plan contours has a lot of business logic of A and B in there. Yeah, we also have nature coins, which also may be specific, but in the back it's just a wallet system that can be used to send tokens to a user or to a certain chain code. The second thing we implemented was privacy through channels. So at the moment, the private data collections weren't available yet. So yeah, we had to do it with the channels. GRB was the only one that could know the ownership of a certain piece of land. And yeah, so we wanted to keep that data private to the GRB. So we created 2 channels, a public and a private channel. And the GRB node was used as a bridge between the private channel and the public channel. Cross-channel writing was possible at the moment. Cross-channel writing was not possible. Cross-channel reading was possible. I'm not sure if cross-channel writing is possible right now. But that had a few issues, so we had a few issues with that. So how did this work? So a user could ask on the public channel, I want to request approval of the owner of that ground contour. Then when an owner logs into the system, we did a request to the private channel to see if there are any requests open. The private channel could communicate with the public channel to get the requests. They get back to the owner, and then the owner approves or rejects on the private channel. And then, because we couldn't do cross-channel writing, an event was posted, and a GRB node was used as a bridge. So they were listening to the events, and then they just updated the public channel if all the data was there. And that way, we did the whole privacy of data. We also worked with Geo Data, which also involves, there are a lot of complex algorithms. You have specific databases for that as well. And those weren't supported by Hyperledger Fabric. The only possibilities that we had was LevelDB and CouchDB. And also, because we wanted to do as much as possible on-chain, we had to do it with those. MongoDB has limited support of geospatial, has limited geospatial support, but that wasn't available at the time, and I don't think there was a ticket open to integrate it, but I don't think it's integrated yet. So we looked at other possibilities, and then we were thinking about setting up an Oracle and do off-chain processing, which might be a good idea, but we wanted to do as much on-chain as possible. So, and then geospatial blockchain, we looked at can we switch the LevelDB or the CouchDB for the contours chain code with another database like PostGIS. We saw that there are just two interfaces that you needed to implement, but they were quite complex, so it was just a proof of concept, so we skipped that. So what we did in the end was just use CouchDB, and then we indexed the bounding boxes of a contour so that we could do intersection with the bounding boxes, and then in the chain code itself, we used derv.js to remove the false positives. That worked for a proof of concept, but yeah, it wouldn't be feasible for a larger data set. So yeah, that's why we also proposed the other two solutions to the client. Then we also have the data. With the Geo Data is also quite complex. There are large data sets that we had to handle with a lot of metadata. We used GeoJSON because we could just store it in CouchDB and we could query on it. But also there, I don't think it will be feasible for a production-like system. So we looked at other solutions that we could look further into, and that's GeoBuff and WKT. They might be better, but we haven't used them. So then for the identity, as I said earlier, we didn't do a connection with the Belgian EID. But we wanted to integrate with the systems they had. They had an identity and access management system. So we used those systems and we made an integration with those systems, because then they could have used those chain codes that we've written for that also in other projects. We looked at it as more like a generic building blocks that they could reuse. Inside identity and access management, inside our system, there is an ID for a user, which is only known internally, and we use that ID on the blockchain so that we don't store any more private data. So we hope that we don't have too much problems with GDPR that way. We also looked at how we could store the keys. At the beginning, we were thinking about we want the user to store their own keys. But yeah, that would be very difficult, not from a user experience perspective. So we also looked at how we could it centralized through an HSM. So we looked at the two possibilities. We looked at how they could work, and we made our chain code that way that they could work in the two situations, so that they could take it further if they wanted to. We made it so that the user in the blockchain inside the chain code has a link with multiple device IDs, so it would be possible that he has multiple devices linked to his account. We also created utility tools for this as well. because there weren't a lot of best practices, we try to combine them inside these tools where there is a helper to generate UUIDs, because we had some issues at the beginning with that. Also invoking other chain codes. There are a lot of things you need to do there, so we had a lot of code duplication because we also had 9 chain codes. So by combining them in these utility tools, we could reuse them easily. Also a base contract which has a basic implementation of invoke and init, so that your chain code contract only has to implement the functions itself. I think this is more or less the same thing that 1.4 will go to, so yeah. Also for development purposes, Hyperledger Fabric has the possibility to set up a dev network, but it was still a lot of work, and we were working with a few people, so yeah, it took up some time. So in the end, we just created a tool that spins up a network by itself, a simple network. And also, when you want to update chain code, it also takes a lot of time. So we also created a tool for that, where you just have a menu below that you can choose which chain code to update, and even that there's a possibility to say, just watch my chain code. If I change something, it will update my chain code immediately. And it sped up the development process a lot. So this is here, it's just spinning up the network, where we also have an advanced configuration object for in JavaScript, because a simple network doesn't have the 2 channels in there. So we wanted to be able to extend the network that it spins up, and by the advanced configuration options, you can specify your own Docker images and so on. So it does all the things you need to set up a network. And then we also have the thing to upgrade the chain code, where it's possible to just say, watch my chain code, and when I change it, it will spin up automatically. Or there is a menu in your terminal where you can choose which chain code you want to upgrade. Right now, only Node.js is supported, so but maybe in the future, we will try to update it, or if somebody else wants to update it, it would be nice. Then for the front-end application, the only thing I'm going to tell here is that, yeah, we also created tools for that, because there was a lot of boilerplate code to invoke and query chain code. So we tried to wrap the Fabric client inside another tool with then higher level functions for querying and invoking chain code, and also for listening to events. There's also a base service in there where you can easily extend and just implement the functions that are provided by the chain code you want to service. So yeah, in conclusions, yeah, for us it was new at the time. There weren't a lot of things available. So we try to look to different things and try to combine them. And we think it's very good if everybody should collaborate and just open source their things. It could only make the blockchain community stronger, and especially Hyperledger Fabric. So we also like it that the Flemish government open sourced the total project. So we really appreciate it. Because another issue we had was we needed to do something with tokens, and we couldn't find a good example of tokens. So to test our tools, we created a token example with the things we did inside the project, and we also open sourced that as well. So you can take a look at our tools we created with that project. And another thing I wanted to say is that we think it's not good to just push blockchain into a corner, because when we were with the client, they drew their own technical architecture and put a blockchain somewhere below. But if you try to understand the technology, look at all the components, I think it can become part of your technical architecture instead of just one thing below, like a regular database. And also, yeah, it's good to bring to think with all the components, and like Hyperledger Fabric has the modular structure. It's good to think with them, but you also need to watch out to not bring too much complexity to the end user, but enough complexity so that they trust the system. So, and that was it. Thank you. if there are any questions. There's one in the back.
Can you elaborate a little more on the token that you created?
Yeah, it was actually, yeah, we had one chain code that manages the token. We know that right now Hyperledger Fabric is also creating a Fab coin, or they are busy with that, but we didn't use that at the time. It's just chain code where you have different wallets linked to the public key of a user. It's just in one chain code that we have written it down, so it was just a number that we stored with the user. And we also had then possibilities to create a chain code wallet. So then the thing is that then that wallet can only be changed from within another chain code. So whenever a token should move from that wallet, we would see that the request was coming from another chain code. And that way we created the wallets for the ground contours, because only the ground contours chain code could manage those wallets. I think that's it. If there are any more questions, I'm still around, so you can always ask.